वेलकम बैक आरपीएस ऑनलाइन क्लासेस में. In the last lecture, I will discuss about conservation of charge. And next topic, next point, fact about the charge. Charge associated with the mass. Without mass, charge does not exist. So charge associated with mass. If mass is absence, the charge does not exist. Like photon. Photon rest mass m naught is equal to 0. So is a neutral particle. The neutral particle. A similar example is a neutron has mass but no charge as a neutral particle. So we can say charge associated with a mass. If a particle have mass, it should be charge, but not without mass. The definition or explanation of charge is impossible because charge does not exist without mass. Second one, if a stationary charge, first one, or a rest charge at rest or stationary means Q rest. If a charge rests, it produces the electric field. If a charge in rest or stationary, it produces electric field. Second one, if a charge in motion, moving charge, electric field and magnetic fields. If a charge moving with a constant speed, a constant velocity, charge moving with a constant velocity, it produces electric field and also electric field and magnetic field, both. But when a charge rests or stationary, it produces only electric field. But when moving, produce both the electric and magnetic field. Third one, accelerate कर रहा हूं. If charge accelerate means change in velocity with respect to time. It means accelerate, speed, change of velocity में change हो with respect to time, increase हो, then it produces this emission of energy in form of electromagnetic waves, but also produces electric and magnetic field. If a charge in accelerated motion produces electric field, magnetic field and electromagnetic waves. So if a charge is rest, it produces only electric field. When a charge in motion, it produces electric and magnetic field both. When a charge in accelerated motion, that's accelerated, is a change in velocity with respect to time, that it produces electric field, magnetic field and electromagnetic waves. Okay? Next, quantization of charge. What is the quantization? What do I mean by quanta? If we know about the Planck theory, about the quantum, first time Planck explained, given a theory about the radiation, like light rays, any radiations have a packets of energy, bunches of energy, bundles of energy. So Planck gives a name, it's called quanta, is also photon. But we are discussing about the quantas. A physical quantity have a discrete values, scan discrete values, is called quantization. If any physical quantity have a discrete value, is called, this is a quantized form. It means, suppose, the example is simple, general example, like this is the stairs, you know stairs, this is the floor, this is the top. So, this one, if your forces steps is long, so you use the 2. But nobody can say how many stairs you climb there. Nobody can say I want to 1.5 stairs. It's impossible thing. 3.5 stairs is impossible thing. He say only 1, 2, 3 and 4. Is integral multiple. In terms of integral multiple, remind that it's terms of integral multiple, not in fractional values. So the quantization, the charge is quantized. The property of charge always be quantized. So Q is equal to plus minus NE. N is equal to 1, 2, 3, so on. Is the charge of electron 1.6 10 to the power minus 19 Coulomb. Is a negative charge. कोई भी electron when it transfer from one atom to another atom is complete integral form, not a fractional form. You can't say half electron transfer from this atom to this atom. It's an impossible thing. Completely one electron transferred from one atom to another. 1, 2, 3, 4, many. This is integral multiple of electron. So the charge is quantized. This form Q is equal to plus minus NE. First time Millikan's oil drop model explain the quantization theory. Millikan's oil drop model. This is an example how many electrons are to be removed from a metallic sphere in order to positively charge it with 1 Coulomb charge? How many electrons are to be removed from metallic sphere in order to positively charge it with 1 Coulomb charge? Charge, how much is a given? Charge Q is equal to 1 Coulomb. Charge of electron (1.6 10 to the power 19 Coulomb. Using the quantization equation, Q is equal to NE. So place the value of charge 1 Coulomb and E 1.6 10 to the power minus 19. So N is equal to 1 upon 1.6 into 10 to the power minus 19. So 1 into 10 to the power plus 19 upon 1.6, 6.25 10 to the power 18 electron. Note it. Another question. A body is charged such that its mass increases by 9.1 nanogram. A body is charged such that its mass increases by 9.1 nanogram. Then how many electrons were given to the body? Determine the value of charge and its nature. How many electrons were given to the body? Determine the value of charge and its unit and its nature. Change in mass del M is equal to 9.1 nanogram is a given in a question. Change in mass delta M is equal to 9.1 nanogram. Just convert into kilogram. Delta M 9.1 10 to the power minus 9 gram, convert in kilogram. So 9.1 10 to the power minus 12 kilogram. Mass of an electron (9.1 10 to the power minus 31 kg). How many electrons is transferred? So delta M is equal to N ME. So N is equal to delta M upon ME. Delta M value 9.1 10 to the power minus 12 upon 9.1 10 to the power minus 31. Just cancel out, plus into 10 to the power plus, in multiplication powers will be added. So N is equal to 1 into 10 to the power 19 electron. Second क्वेश्चन में पूछा जा रहा है सेकंड चार्ज. So you have a number of electrons. Using the quantization equation, Q is equal to Ne. N 1 into 10 to the power 19 a charge of electron 1.6 into 10 to the power minus 19 Coulomb. So Q is equal to 1.6 Coulomb. मास इंक्रीज हुआ था, सो चार्ज विल बी नेगेटिव. अगर किसी बॉडी का मास इंक्रीज हो रहा है, इसका मतलब उस पर इलेक्ट्रॉन एक्सेप्ट किए हैं. जब इलेक्ट्रॉन एक्सेप्ट होंगे तो चार्ज उसमें इंक्रीज होगा, नेगेटिवली चार्ज. Next, Coulomb's law. Previously, the charge unit of charge is Coulomb. So, Coulomb's law. What is Coulomb's law? Two point charges should be reminded, the point charges at rest Q1 and Q2 is separated small r distance. Repulsive force between the charges Q1 and Q2, but if the charge is opposite nature, it's the attractive force. If charge in a same nature, it's a repulsive force. So both the forces may be depend on the nature of charge. If two point and rest charge apart from a certain distance small r, Q1 and Q2, the force between two steady charge, repulsive or attractive, is the product of two steady charge magnitude. The magnitude of two charges, the product of magnitude of two charges, the force F is directly proportional to the magnitude of the charges Q1 and Q2, and inversely proportional to the distance between the charges r square. The force, attractive or repulsive, is directly proportional to the product of charges and inversely proportional to the square of the distance. So F directly proportional to Q1 and Q2 and F directly proportional to 1 upon r square. Okay? And this force applying, this is the joining of line joining हो रही है ये यहाँ पर देख लीजिए आप. Along the line of join both the charges, not a such type of force, not this type of force. Along the line joining the two charges, so F proportional to Q1 and Q2, F proportional to 1 upon r square. Combining both the equations, F proportional Q1 Q2 upon r square. So F is equal to K Q1 Q2 upon r square. K Q1 Q2 upon R square. K is the proportionality constant. K is the proportionality constant. Its value K is equal to 1 upon 4 pi epsilon naught. Epsilon naught is called epsilon. Epsilon naught or 0, as you like. Epsilon naught and epsilon 0 is called permittivity of free space. Permittivity of free space. Epsilon naught is called the permittivity of free space. Its value 8.85 10 to the power minus 12 Coulomb square upon Newton meter square. And the value of K is equal to 1 upon 4 pi epsilon naught is equal to 9 into 10 to the power 9 Newton meter square upon Coulomb square. Permittivity of a free space. So, the force in vacuum or air F naught is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. And force in any medium F medium 1 upon 4 pi epsilon Q1 Q2 upon R square, where epsilon is the permittivity of a medium. Permittivity of मीडियम. नोट करें इसको, आप पॉज कर लें वीडियो को. द डायमेंशन फॉर्मूला क्या होगा एप्सिलॉन नॉट का? बहुत बार बोर्ड में इस बात को पूछा गया. डायमेंशन ऑफ एप्सिलॉन नॉट. यू फाइंड द वैल्यू ऑफ एप्सिलॉन नॉट एफ आर स्क्वायर अपॉन Q1 इंटू Q2. सॉरी Q1 into Q2 upon F R square. So epsilon naught is equal to, this is a Q square upon F R square. Q is a charge, F is a force, R the distance between the charges. So epsilon naught Q, the dimension formula Q, charge AT. So A square and T square. And force M L T to the power minus 2 and R square L square. Epsilon naught A square T square upon M L cube -2. Clear? So the dimension formula m -1, l -3, t 4, a 2. This is the dimension formula of epsilon naught या permittivity of free space. For the definition of 1 Coulomb, definition of 1 Coulomb. We know that F is equal to 1 upon 4 pi epsilon naught Q1 Q2 upon R square. If Q1 Q2 is equal to Q1 is equal to Q2 is equal to 1 Coulomb and R is equal to 1 meter, then F is equal to 1 upon 4 pi epsilon naught. So this value is 9 into 10 to the power 9 Newton. The force between the two rest charges apart for unit distance is 9 into 10 to the power 9, then the charge will be 1 Coulomb. If the force between two steady or equal charges apart and unit distance from each other, then the force will be 9 into 10 to the power 9, then the charge will be 1 Coulomb. अगर दोनों चार्ज 1 कूलम दूसरे से आपको दिख रहा है यहाँ पर, फोर्स 9 × 9 अगर यूज हो रहा है दोनों चार्ज के बीच, डिस्टेंस 1 मीटर यूनिट डिस्टेंस है, तो चार्ज 1 कूलम होंगे, इसे कंफर्म. सो दिस इज द डेफिनेशन ऑफ 1 कूलम चार्ज. डेफिनेशन नोट कर ले. If the force acting between two equal charges placed in a free space or air, the distance of 1 meter apart is 9 into 10 to the power 9, then the magnitude of each charge is 1 Coulomb. नेक्स्ट टॉपिक जो अपना है वो है रिलेटिव परमिटिविटी. इसको डाइलेक्ट्रिक कांस्टेंट भी कहते हैं. वो अपन नेक्स्ट लेक्चर में इसको पढ़ेंगे, डाइलेक्ट्रिक कांस्टेंट क्या होता है. थैंक यू.